everyone, I am here today with Flynn, and Flynn published a blog post that was really talking about generating faces with deconvolution networks, and it's really, really cool work, and I'll let Flynn explain some of his kind of inspiration and kind of what he thinks might happen or what type of applications you might have with that. But I saw it, and there's all these different faces, and we'll show that in a minute. But it's just really cool to kind of see how the model actually thinks about a face and how it generates it. And I wanted to learn more. Flynn, thanks for coming on and talking to me about it.
Mm-hmm. Yeah, of course.
Flynn, I would love to know, kind of tell me a little bit about what was going on before you started working on this.
So I was a graduate student at Johns Hopkins, and we just had a deep learning reading group back in the spring. And one of the papers we went over was this one. I forget the university and the author. But basically what they did is they took a bunch of 3D models of chairs and furniture and cars, and they just, by showing a network all these images and giving them the parameters of what the thing they wanted the network to draw was, the network was able to actually learn like some sort of some sense of 3D space, and was able to most impressively also interpolate between different styles of chairs, different styles of cars and whatnot. So one thought I had was just how well could this work for natural images? And I just happened to stumble upon this really kind of contrived but perfect for this sort of situation. It was a data set of just faces of people showing different emotions. And I thought I might as well try it. And the results were just very spooky.
Yeah, and well, we'll show that in a minute. Actually, let me share my screen. I have your post up here, and I think you have kind of a video. Can you see my screen here?
Yeah.
And I think this video is kind of what you're talking about a little bit with the with the things that they publish, and I think there's a link here. But yeah, watching these chairs kind of go through. So you're watching this kind of thinking like, this is incredible, which I think anyone watching this thinks that. But like, what are you kind of thinking when you see this? I mean, did you immediately connect it to wanting to try it with faces, or what was that process like?
Well, it just seems like just by the way the problem is formatted for this work, that it could be reused for any sort of data set that has a very clear one-to-one relationship between the labels and the image that it is. So like for this, they input the style of the chair, what orientation it's at. Trying to remember what other things. I think it's just mostly those two parameters. But because those parameters so clearly describe what object the network has to draw, the network is able to learn that relationship pretty easily. So it could, theoretically, it should just generalize to any sort of data set.
Right. Wow, that's really awesome stuff. So what was your kind of your experience with developing up until that point? Like, I mean, had you been contributing kind of code in your graduate program? Like, what was kind of your experience level when you saw that work?
So I was just starting to get into some video understanding research that's going on at Hopkins here. And I honestly, at the time, I did not know too much about deep learning. I knew generally like a basic understanding of computer vision, had like a basic understanding of machine learning, but I hasn't really done too much with it. Before that, I was an iOS developer for several startups. So it was just like broke into a very new world.
Yeah, I feel like that's a theme with a bunch of my guests on the show is that like it feels like there's this perceived gap between contributing something interesting and kind of diving in. And I think that the developers who just kind of roll up their sleeves and say, this is cool, I'm going to try something out and see where I can get, can do some really cool work. So it sounds like you're kind of on that same path.
Yeah, somewhat, yeah. And I also feel like this, the results for this were just like a very happy accident that I wasn't expecting, like the weirder stuff that came out of this.
Yeah, let's take a look. Are you able to share your screen from your side of the Hangout?
So essentially what this network did is you show it a bunch of images of faces, and you give it as input the parameters of what to draw. And for this model, the three parameters were the orientation of the face that you want to draw, the identity of the person, and the emotion that they're displaying. So for this example, it's interpolating between all the different identities that the network can draw. And what was very interesting is that it actually figures out like what eyebrows are, or it gets like some sort of concept of what eyebrows are, what the nose is, what eyes are, what the mouth is, and kind of gets a realistic understanding about how it should interpolate between each one. It doesn't just fade in between them like you might otherwise expect.
So when you say that, you're kind of saying like there's this idea of that it's not only saying that there are, let's say, 50 different eyebrow type sets. It's actually kind of understands the transition from one eyebrow set to the other eyebrow set.
Yeah, yeah.
Okay.
Because another relationship it could have learned potentially is that just kind of like crossfade the two images.
Right.
And you might see like 4 eyes in the middle of the interpolation, whereas in this, it just has one set of eyes. And I have thoughts about why that is.
Yeah. Why do you think that is?
So I think the main thing about this is that the reason it's able to figure out the different parts is because we gave the model, you're essentially telling the model, you have a constrained number of resources, and with those resources, you need to figure out how to draw the thing that I want you to draw. So just by virtue of the way that you pose the problem, by making the loss function the way it is, it figures out that the most efficient way to draw someone's eyebrow is to have the same filter in the network draw the eyebrow over and over again.
Right.
And really what it's most likely learning is just a bunch of like affine transformations where it's just pushing a little dark line around the screen.
Wow, yeah.
Because of that, it allows the network to actually like generalize properly.
Yeah, it's so interesting. And so we're looking at emotions now.
Yeah.
And so it's a culmination of eyebrow, smiling. And do you know if each one of these actors in the kind of the data set that you started with, are they like, did they express all these different emotions, or like, did they take, okay, smile in this one, look surprised in this one, and they took an X amount of set of faces?
Yeah. So each person, in the data set, there's an example for each person showing each one of the 8 emotions that they can display. So it's really just interpolating between examples that it's seen in the training set. It's not trying to generate anything particularly new besides just what's in between the 2 images.
Right. So in theory, I shouldn't say necessarily in theory, but some of these faces that we're seeing, and as they shift around, is there like an original that you can actually compare and say, hey, this person, this is kind of their standard face with no expression, and then they smiled, and this is what the model predicted their smile looked like, and this is what the photo they took in the photo shoot smile. Does that make sense?
Yeah, you can reference essentially like the keyframes that it's animating between.
Cool.
But there's no reference for the parts in between.
Right. That's interesting. Yeah, I mean, as we watch it looks like it understands the idea of muscles, right? Like, you can see the drawing back of the face. You can see the squinting of the eyes. It's really interesting.
Yeah. And I'm really not entirely sure how much is that it actually learned some idea about like what facial structure is,
sure.
Or if that's just the animation is so simple that it looks realistic to us.
Right. Yeah, that's a fair point. Cool. So, yeah, take us through kind of more. I'd love to kind of hear more. So this is identities plus emotions here.
Yeah. So yeah, going between both of them at the same time, it gets
wow.
It's very realistic, definitely.
Yeah.
But what the more interesting stuff is when you look at the things that the network was unable to learn. So for example, orientations in the data set, you only get examples of each person at 0, 45, and 90-degree angles, but you don't get the angles in between those. And that didn't actually seem to be enough information for the network to actually get an idea of like what a person's face is at different angles, which was kind of surprising because not necessarily surprising, but I do feel like if this was like a 3D vision problem and you're trying to do like volumetric stereo or something, you probably could just from those angles get an idea of like what the 3D shape of the object should be.
Right.
But what's interesting is that this wasn't enough information for the network to learn, so it kind of came up with its own thing. And what's really interesting is the back of the head, what it thinks the back of the head of the person is. It really just keeps the ear fixed in one place and just kind of pushes the person's face from one side to the other.
Right. That's interesting.
But so yeah, it doesn't learn orientation as well. And I think
Right.
this is actually one of the key points in what makes the next few things I'm going to show so fascinating. So another thing I started playing with is just can it create like just random arbitrary combinations of identities and emotions. So I really just put in the identity and emotion vectors are, or the emotion inputs are represented as one of k encodings. So essentially it's a vector. There's 57 people in the data set, so it's a vector of length with 57 elements in it. And you put a 1 in the position where you want that person to draw. So for example, if you want to draw person 1, you'd have a 1 in the first position in that vector, and then a 0 everywhere else. If you want person number 2, you put a 1 in the second position in that vector and 0 everywhere else. And this essentially has the idea, this is essentially like, it's kind of like saying I want 100% of person A or I want 100% of person B.
Right.
Or you can say when you're interpolating between it, you can have like 50% of person A and B at the same time. So to create these images, I started putting in random vectors, which were constrained to unit length, so that if you summed up all the elements in it, it would all go up to 100%. So it would be something like 60% of person 1, 30% of person 2, 10% of person 3. But it would all add up to 100.
That's really that's super interesting. I was on the airplane and I was kind of taking a look at your work, and my wife kind of looked over my shoulder, and she's pregnant right now, and so she was like, hey, do you think that could work to, like, what would our baby look like? And thinking of the way that you just described that with saying, 50% this and 50% that, makes me think like, hey, there's a little mini service of taking two faces and saying like, this might be the outcome of what a child might look like from these two people. Is that something that is within kind of the realm of what you're talking about here?
Yeah, possibly. You'd have to train the data set with both of your faces inside of it. That might take a few hours to do, but that would definitely be something that would happen. You'd be able to get an idea of like a cross between a mixture of two faces.
Right. That's awesome. Cool. Sorry to interrupt, but yeah, okay, no. That's really cool.
Yeah, and if this data set was bigger, if you actually had a data set that was full of people at different ages and things like that, you can actually probably do something where you can predict what someone's going to look like as they get older.
Right.
So for example, one person suggested to me this might actually be useful for, say, like Amber Alerts, where a missing person's been gone for like 7 years.
Right.
You have a photo of them when they're 13, but you want to find out what they look like now so that you can actually realistically predict what they're going to look like.
Yeah, and I think of the Googles and the Facebooks, and this topic gets brought up a lot on the show is, they have a massive amount of data set, and I think of Facebook's structured data to be able to say, hey, this person, signed up and said their birthday was in 1987, and then we have a photo of them uploaded in 2014, 2015, 2016. They could. It's interesting to think of what they could do with it. And I know they're all over that type of stuff, but
yeah. The problem with using something like the data that Google or Facebook might have is that the data for this model has to be very clean and very kind of contrived. So just like photos in the wild, what people would put as their like Facebook photo, stuff like that wouldn't really work. But things like people's driver's licenses, if you can get access to like that data set, that actually might work pretty well.
Part of my mind wanders just thinking of getting better at taking a photo in the wild and kind of adjusting it to fit this model a little bit better. I think of, I don't know the right way of phrasing this question, but I would think over time that someone like Facebook could get more sophisticated at cleaning up their data set, even with kind of these messy photos, to be able to train models to hone in specifically on, say faces that are directly straight on and well lit, and maybe it cuts out the background for it. And with that data set, is that data set, from at least from your understanding of it, still too messy if they were able to do that?
No, that actually might, as long as they're like front facing people, I think, and like the eyes are in the same place for every photo, then that should be good enough. I'd imagine.
Yeah, and sorry to make you speculate on this hypothetical
technology. Oh, no.
Yeah.
No, I actually have an example later on.
Cool.
That's your data set.
Cool. Yeah. So you're kind of playing around with these filling in the different elements of what makes up the face, and so yeah, like what are some of the things that, like, are the bottom ones you kind of going over 100?
No, so all these ones are what I call like legal inputs. So the angle is always like a valid angle between 0 and 360.
Hmm.
Or the way the angle is represented is you give it the sine and the cosine value so that 0 and 360 degrees look the same to the network. Um, but basically, like these are all like inputs that make sense. So on the top row shows generations that look pretty reasonable. It seems like whenever you do this and you just put in random vectors, you don't try to control it at all besides just making sure that it's constrained to unit length. You get this kind of like awkward, plain looking person. Like you can kind of see they all have like very awkward expressions and they don't look too notable. The bottom row is the examples of people that didn't really come out right. And this is mainly because of the orientations, because I wasn't able to learn that relationship. These generations didn't really look too well, but they do look very interesting because they have like mouths in different places, eyes in different places, and whatnot. So that one question was the next obvious question is what happens when you do like illegal inputs. So like you say, I want 200% of person A, or I want negative 100% of person B, or I want some mixture of people that exceeds 100 or is even less than 100%. And then the stuff that came out of that were these amazing like Francis Bacon type portraits.
Yeah.
Of just faces like contorting in different ways.
Hmm.
Um,
Wow.
yeah, so these pictures are on my blog post if you want to look at those. But what's really fun is earlier I was doing this. I was not using what's known as batch normalization in the convolutional network. And it came out with these much more gory pictures. And they actually look like much more frightening. It's like, I don't think it's in this example. Oh, yeah, in this one, if you look at the bottom right picture, you can kind of see like their brain almost and like their eyeballs popping
Yeah.
out. And what's actually a fun story about this is when I was first working on this, I was using my advisor's computer, which was in his office at Hopkins. And the way it would work is whenever I would log on, he would be able to see whatever I was doing because we were using TeamViewer to do it. So the first time when I tried this experiment and I checked the results, he apparently was having a meeting in his office. So during the meeting, he had the monitor on his desk and like right in front of whoever he's meeting with, right in front of their face. And then it just lights up and then you see all these faces pop up.
That's great.
And then what's really cool is then if you take all these legal inputs and then you do like random walks for this space, you get this animation that looks is very mesmerizing, with just faces morphing into each other and sliding in and out.
It's such an interesting application of the work too. I mean, you talked about being inspired by the furniture and whatnot, and I think anytime anyone does work with faces, our brain is just so finely tuned to see faces and understand them and kind of get this sense of what's going on that I find the work always super interesting because I think our brain is just kind of taking it to the next level with our facial recognition.
No, totally. That was one thing I thought of going into this because I was thinking, hey, this might not work, but if it fails, it's going to fail beautifully.
Right.
So that was just like extra motivation to go at it, especially even though I didn't really know what I was doing at the time.
Right. Yeah. That's great insight. Oh, that's awesome.
Yeah, so this video, there's a 10-minute long video of this on my YouTube if you want to check it out.
Yeah, I'll put a link. So yeah, I'll put a link in the description of not only the blog post, but your GitHub code as well, and some of these YouTube videos. I think you have linked in there, but I can link additionally. But it's just awesome to watch it play out.
Yeah, yeah. So another thing I tried was using this other data set called Yale faces, which was a much more messier data set. And I tried doing the same thing like I was doing before, where I train on this and then try illegal inputs, see if I can come up with some spooky faces for Halloween, especially since this data set has very harsh lighting. And the same sort of thing happens with this. You get these very like ghostly figures, and you see these very like zombie-esque faces.
Yeah, that is. There are some really creepy ones in there, and I imagine, I'm thinking of like the applications of something like this, and even in this context, where you could say, you know, I'm thinking of even shooting a movie, right? And then there's the face just kind of jumps out at you. And I think of a special effects director having the ability to kind of say like, okay, let's generate 20 of them and I'll see the scariest one that I'm going to jump out. I mean, some of these are, if you did a jump cut, yeah, that would be pretty freaky.
Yeah. So when you do random walks like you did before, you get these kind of like jumpy horror movie type animation.
Yeah. Wow.
So that's exactly like what you were talking about.
Wow. On this one, is this people sitting essentially like at a webcam in a room? Is that like what's going on in the background?
The background, they had some sort of lighting harness, I think, because this data set, they have pictures of everyone, but instead of emotions and orientations, they have like a set of poses that they would do, and they had lighting coming at from like a bunch of different angles. I think there's like 20 something different angles that would come out, and I think they had a lighting harness around the person. So that's what those bars are in the background. It would go off when they take the photo at different times, so they get all those orientations or all the lighting orientations.
That is cool. That's cool.
Yeah, but the problem with this data set is that the background changes, so the orientation of the camera moves for some of the pictures. And there's like people in the background. There's grad students doing whatever work they're doing. So that's kind of why you see the background kind of morph around like it does.
Right.
But it was surprisingly, it shows something visually interesting, which I was pretty happy about.
Yeah. I mean, like you said before about failing beautifully, it fails in a very interesting way.
Yeah. Yeah. So one question that comes up is like why this network is doing anything that it's doing. So one experiment I tried was saturating the emotion. So I talked about how you would put in like 100% of person A and then 100% of person B. This experiment was just taking the input and starting from just having everything be 0, slowly move it up until the whole input everything is at 100. And this was just to get a sense of like what sort of relationships these inputs are actually controlling. So for emotions, when you do that, what you find is that the person's face doesn't really move that much at all. And one reason why I think this is, I haven't actually done the rigorous work to actually verify that it's actually doing this. But I think that for the emotions, it just learns like what the affine transformations have to be in order to move a person's lips from one to another. So this is animating, by the way, but it's not moving at all because all the emotions are conflicting with each other and pulling in different directions. So it just doesn't move.
Interesting.
Which way? He gets kind of a like puckered sort of face.
Over time, yeah.
Yeah. But that kind of supports that the emotions that it learns are just it's just learning how to move the parts of the face around.
Right.
But for identities, it gets much more interesting. So pushing this from 0 to 1, what you'll actually see is the person's face just completely rip apart. So their face will melt, and then the background actually starts to show colors of flesh and all of that.
Huh.
And I feel like the reason so again, haven't done like the rigorous work to verify any of this, but I feel like the reason is because the identity, because that's actually building the type of face, like the shape of the head, and is dictating much more about like what goes where in the picture. All those activations are starting to add up together, and then it's just really just completely saturating, which is why you see like the white background show up where the person's face should be. And then because there's so much in the background, that's why it shows like flesh colored and the brown color.
Yeah. Yeah, that's interesting.
Yes, I don't know how much more.
Yeah, I mean, I would love to keep learning more. I mean, how much do you got?
Quite a bit. Well, I don't want to show this yet.
Okay.
But I did some experiments just like visualizing what the inside of the network is doing. I guess we can look at this. I don't have any huge insights about this, but it's cool to watch.
Yeah.
but you can see like this is at about one of the intermediate layers, like the representation of the face at what each one of the filters in the network is showing when it draws it. And you can see that a lot of different kernels are learning to draw eyes, different kernels are learning to draw like the background, different kernels are learning to draw people's faces. But one interesting thing that you would see from this is that in some of the layers, you get a lot of repetition that kind of suggests that it really didn't need this much power in order to draw the person's face. So like for this one, you see a lot of the kernels that show a high activation just in the background.
Right.
When really you only need one because the background, that's where the least information is happening.
Right. So when you say that, do you mean that there's kind of opportunities for increased efficiency in kind of how the model is analyzing this stuff so that you could run it maybe quicker or on like less processing power?
Well, I mean, you can learn it with fewer parameters in the network.
Got it. Okay.
So this one had like this has like several million parameters, and you can possibly do it with probably like half of that, I would imagine.
Right.
But that's still an experiment. That's still an open question. I haven't really explored it too much. And what's also interesting is that some of these kernels learn very funny relationships. Like if you look at this one, the one on the bottom that's just completely black.
Yep.
That kernel is not really doing anything. What it is doing is it's learning the border at the side. So you see there's like a big bright line on the side there.
Yeah.
So really all that kernel did was the network figured out, hey, I can get extra points on the loss function if I just make this a really high activation on the border where typically that's 0 padded.
Right. Huh. These are fascinating as well. Wow.
Yeah. Yeah, I feel like there's a lot more analysis that could be done with this, because what's also really interesting about this is that because it's producing visual results instead of just like numbers.
Right.
That's a way that we can probably that's a way that's easier for us to understand, and it might be worthwhile to go through and at least like build in more intuitive knowledge about how networks work.
Right.
Because we can actually interpret the results intuitively instead of just like seeing something happen where you take a photo of a lamp and it says it's a goat. Right. You don't know why it says that, but for this, it's a bit more interpretable actually.
Yeah.
Why it's doing what it's doing.
Let me take a moment to say that this wouldn't be possible without companies like Amazon.com. If you have experience with machine learning and are looking for a new challenge, they have over 100 opportunities available. Be sure to check out the link in the description, and let's get back to the show.
So what was kind of like the most challenging part as you were going through playing around with these different models? Was it learning how to develop? Was it actually, and I don't mean learning how to develop, but I mean specifically working with this network, or like what was the most challenging part when you were trying to do what your brain was thinking about what you wanted to do, if that makes sense?
Overall, I think this actually was a pretty straightforward kind of model to implement. It really is kind of, after working with, I'll say easy. It's probably not easy for other people to go out and try it, although I highly suggest that people do. But the hardest part was there was one interesting bug once where essentially what would happen is the model would train. It would keep training and training and training for a bunch of epochs. And then around like epoch 50, you would have like a pretty good picture of the person's face by then. And then in the next epoch, the whole output would just be just white and blue. Just a big blue blob all over the place, and just completely saturated, not showing a face anymore. It just completely exploded, and it wouldn't work anymore. And I think the way I solved it was, I think what was happening was essentially the way that the activations work in a network. Typically you use like regularized linear units. Which is for the activation, for whatever input goes into it, if it's below 0, you just output a 0 no matter what. And then if it's above 0, then you just output whatever it is. And I think what happened was at some point, some activation way in the bottom essentially passed the threshold to be 0, to go from negative to positive. So then that activation started firing. And then that had a chain reaction where it just like exploded the output completely, and just made it saturate the way it did. I don't have any photos to show.
Yeah, no, it's fine. Yeah,
Um,
that's interesting.
but
Yeah.
the solution for it was batch normalization. But that was kind of an interesting thing to understand. I think that problem might be called like exploding activations or something like that. But I think that's actually a thing that happens in networks.
That's cool. That's interesting. So yeah. When you kind of doing all this work, and we've talked a little bit about some of the applications that might come out of this, are there other applications that when you see this that jump to mind for you?
Definitely animation, I think. Yeah, so that is actually the next step where I'm planning to take this is building animation software to build these animations. And I actually have I've had several artists come up to me and we're interested in potentially making something out of this, and like taking a bunch of photos of people, using that as a data set, and then creating like artwork or whatever you want to call it.
Yeah, it crosses my mind to it's like if you had full control over the data set and you had the ability to say manipulate the face, as you're going to train the model, it makes me wonder, if people were all wearing masks or if they were all wearing prosthetics or something like that, right? You could bias the data set in a certain way that could illustrate in some sort of artistic style that you were going for, which is, there's just so many different ways that my mind is wondering if you were to do a project around that is pretty cool. Yeah. To control the data set, right? It's like what power do you get by manipulating that on?
Yeah, and I think you can get a lot. And what's interesting is that the workflow, if you were going to do something like that, is not much different from film. It's not much different as if you were going to make a movie, because you go out and make a movie, you have to go take videos, everything, then come back and edit it and have the computer do all this post-processing to it.
Right.
But this is very same. It's just it's a new sort of medium, and it's very difficult, I would think, for someone who's not familiar with deep learning to be able to go through that.
Right. Yeah, that's pretty cool. Cool.
So one thing I hope in the future is that hopefully in the next few months or so is that I'll be able to produce something that kind of shows an example of how we can use it for that sort of creative task.
Yeah, so I was going to lead me in my next question. I was going to say, like, what you mentioned, building some software around this, is like, what are you up to next with this? And are you working for yourself? Are you still in school? What's kind of the next few months look like for you?
Next few months is I'm going to build the software for this to make animations with it, and see how that goes. And right now I'm out of school, so I graduated with a master's, and I'm not planning on going for a PhD anytime soon. So I'm just off searching for a job at the moment.
Cool. Well, I really appreciate you kind of taking us through your work. It's really awesome to kind of see how it all plays out. And we mentioned this before, but the faces being involved just really makes it visually dynamic and interesting. So appreciate you hopping on the show. Is there anything else that you'd like to share before we close?
So I actually have one last little experiment that I think is interesting enough to show.
Cool.
If I can just get through all my slides here. So here's one experiment I had. So for the data set that I used, every person is present. Every person is showing one of the 8 emotions that are there. So one question I had is, what happens if you have just one person but not displaying all the different emotions? So what I did is I took a photo of myself in the same style that the original photos were taken, and I inserted that into the data set, and I tried to create hallucinations of myself displaying different emotions. So this is what the model came up with, and this is one of the earlier ones before batch normalization. And you can see it kind of gets like an interesting sort of sense for how this works. But one notable thing is that it tends to like, I don't really have much facial hair. I only have like, I think when I took the picture, I had like just shaven or something. But it really seemed to like catch onto my mustache. So especially if you look at like the bottom photos, it has a very dark line for where my mustache would be.
Right.
So one interesting thing that happened is I tried when I tried animating to go from a neutral, this was the photo that I put in to Surprise, which is the photo that I didn't have in the set, what happens is it animates like you would expect it to, but then that mustache just starts to do a little spunky thing, and it actually turns into a mouth.
That's really interesting. Yeah.
And what was the reason why the network ended up doing this, I found out, was because no one in the data set had facial hair at all. So because huh?
And you had a slight mustache, you said?
Yeah. So because I had like a bunch of stubble around my face, the network really picked up on that, and it thought it was something that it really wasn't.
That's
But
awesome.
that's kind of a typical, like, very plain machine learning lesson, is make sure your data is actually representing what you think it represents.
Yeah, that's awesome. Cool. Well, I really appreciate you joining the show and taking us through everything. Take care, and thanks again.
Yeah, thank you.
All right, see ya.
All right, bye.